Hi guys, long time no see. Once again we are back here at my Powerwall, and today's topic is a change on the inverter. I'm now here at the end of the testing period. The Powerwall was finished about 2 months ago, and it was kind of the phase of beta testing, and that part is already done. The software is already completely finalized, the hardware has also changed. There's already a new controller board on this, a PCB which I made. So this will be shown in the next videos which will come soon. But today's topic is only about a change on the inverter, and what this is about I will just tell you and show you. So what is the problem with my inverter? I have the SUN inverter here, 2 kilowatts version, grid-tied battery inverter, and well, there's no problem with the inverter. The inverter works really well, no problem at all, but my Powerwall has too much energy. Who has followed my series about the build of the Powerwall knows that at the moment I am discharging the energy which I am storing during the day to the owner's apartment of our resort. And yeah, it's simply said, we don't have enough demand of energy to use up the energy we could actually store during the day. My option, how I can improve this situation, is actually to discharge the energy not just in the owner's apartment. I have to basically go one step up and discharge into the whole phase. So this will give me the opportunity to discharge into the owner's apartment and other 3 guest bungalows. So that should be better, and we can use up much more energy. But to do that I have a problem, and this has to do with the CT of the inverter. You know, the inverter has here a CT connected, and that one goes here to my main distribution board, and I will show you what is the problem exactly there. So here in my main distribution board the situation looks like this at the moment. That I have here is the original CT of the SUN inverter, and it is basically plugged over this one bus bar which goes through the main breaker of the main building into our owner's apartment there. And this bus bar is a 15mm wide copper bus bar. The original CT is a CTSA 016, that's the name of it, and the 16 especially, that number stands for a 16mm hole. So 15mm bus bar, 16mm hole on the CT, fits right well. But the problem now, you see, I want to discharge into the yellow phase here, the phase number 2, and also kind of utilize this one lane. This goes to 3 bungalows. So I need to connect now the CT somewhere upstreams here. But here, this main bus bar here is an 18mm bus bar. So I cannot use this CT anymore. It is not big enough from the hole. But that place actually is not very good accessible, so actually I want to connect the CT somewhere here on the incoming main cable, same place as the CTs from the smart meter. But for that, as I said, we need a new CT, and I will show you how to get one and what you have to basically take care of. So here again, this is the original CT. It's a 100 amps 50 milliamp ratio, and here the 16mm hole. So this one is good enough for the smaller bus bars, but not anymore for the main cable and the other bus bar. So this here is the KCT24 split current transformer, and the 24 stands for the 24 millimeter opening here, the hole. And here you can see the different versions. So you have to choose the input current, and then you have two options. Some current transformers, they put out a milliamps or amps output current, or they put out a voltage. So in our case, the original current transformer is input 100 amps and output 50 amps. We can choose that, and this will be manufactured by the company like this and then sent to us. The second thing we need is the GX12. So don't mistake, it's GX12, not 16, not 20. So it's the smallest available, with 2 pins. So basically this one, we only need a female plug of this. So very simple. Once we get the 2 items, we can then build this new current transformer. And as we were just speaking about this, the 2 items already arrived. Of course, I ordered it before. So this is the KCT24. You see the very big opening now. So this can fit really big cables. And the rating, as you can see, 100 amps and 50 milliamps output. So that's the same as the original CT, and after we connect this to our inverter, it should work exactly as the other one. The second item, the small GX12 female plug, and we're going to solder these 2 things together. Of course, I cannot tell which end belongs into which pin, but you know, it depends about the direction, which is marked here about current flow, but it doesn't really matter. If the wire is wrong, on the wrong pin, we just need to turn the CT over by 180 degrees, and then it will be correct. Okay, so unfortunately this CT only comes with a 1 meter cable, so this is not enough for my distance between the main distribution board and the battery cabinet. So we will add an additional meter of wire, and then it should be enough. So 2 meters from point of measurement to our inverter. That should be fine. Okay, so let's go and get a soldering iron and some heat shrink, and we build this. So here you can see the difference between the 2 CTs, from a 16 hole here to the right to a 24 millimeters at the left. It's a massive difference between those 2 CTs. I have prepared an extra 1 meter, about 1 meter 20 cable to extend the wire from the CT, and for the GX connector, you have to unscrew the top part, the plastic part, from the metal part, and then you can access the pins. So I have twisted the wires together. As I said, there's no need to think about a particular order of the connections. We only have it's a 50-50 chance that later on the CT will be connected according to this arrow which is shown here. If it's wrong, then it's your choice. Either change again the connections, the solder connections, or you just turn over the CT with your cable wherever you do the measurement. Okay, let's put some solder on it, put it together. Connection is done. We put the heat shrink on top of it, shrink it. Put another one on top of those two. Okay, so we have an extended CT cable now, and the next we do is connecting this GX12 female plug. I'm splitting the cable here, taking off the insulation. Put a little bit solder on the wire. So for the other end, with the plug, I have prepared some bigger heat shrink, two parts here, because one will cover all the plugs later on, and the other one then just the transition from the cable through the plug after we shrink that one. Push the metal parts over the wire, and then there is a heat shrink for inside. Push this one. So and now we try to solder these two wires on these small connectors here inside the plug. So this will be fun. Maybe our third hand can help a little bit. Okay, let's try this. Soldering the other one a little bit. Okay. This will work like this already. I'm taking now this inner tube, but here there's a little bit of solder, too much here. Okay, let's remove this. Push the first shrink on top. Then the connector casing, screw it together. Okay. Fix it. Okay, now I'm taking the big one on top of this. And the second ring. Just to close this up more nicely. Okay. So that was it. Fast and easy job. We have our new CT. Cable connection number 1 and the GX12 2-pin connector on the other side. So we are ready to go to the Powerwall again and disconnect the old CT, and then we will put this one into the main distribution board on the cable which I showed you before, and just plug in the new CT to the inverter, and then everything should work as before. Okay, let's go there. Okay, I have installed the new CT. It's right below the 3 of the smart meters on phase number 2. So let's go to the inverter and check the indication there. Here is now the indication on the inverter. Here below is the voltage and then the value coming from the current transformer, and it is sensing 63 watts. 63 watts. We have to now check if this is same as the smart meter shown, because I have also a solar area on that, so it could be export also. So let's check here. This is the great thing. Now I'm reading all 3 phases now on my box, and here we are showing on the second line is phase 1, phase 2, phase 3 power, and now you see on phase number 2 655 174. Let's check it again on the down, 177. So the city is correct, the direction is correct, and yeah, it was already everything what we had to do. Just go back to the main building and give it a final thought. The CT of the SUN inverter is changed to one with a bigger opening, so I could use it on bigger diameter cables to measure my current. It works as expected. We have now the opportunity to also push energy into 3 more buildings, not only in our owner's apartments, so we can really cycle the full capacity of the battery on probably a daily basis, or at least when there is guests in the hotel. Okay, that was it already for today, and please watch my series about building of the Powerwall if you didn't yet. Please like, subscribe to the channel. It always helps to get some new viewers. There will be soon some videos about the end of the beta testing of the Powerwall, and I will show you then the new controller board and the features and function of the controller. So thank you for watching. Come back next time, and I'll talk to you in the next video. Thank you.